Today we are going to learn the third types of measurements. It's measures of relative standing. Specifically, there are 5 measurements that can be used to measure the relative standing. Measures of the relative standing are designed to provide information about the position of a particular values relative to the entire dataset. Okay, we're going to learn percentiles, quartiles, IQR, percentile rank, and z-score today. Okay, let's have a look at them one by one. The first one is called the K percentile. Okay, first I'll introduce the method to calculate the K percentile, and I will set you an example to practice how we can calculate the K percentile. Okay. First of all, for a sample, if sample size is n, the method to find the K percentile is first, we sort the sample in an ascending order. That means from the minimum value to the maximum value. Second, we need to find the location of the K percentile, denoted as LK. LK is the minimum value of n, and n plus 1 times k divided by 100. It's the minimum value of these two values. Third, find the value of K percentile pk. pk is the integral part of the LK plus 1 element minus the LKth element times the decimal part of LK. Okay, the meaning, last, we need to understand that the meaning of the K percentile pk, which means the probability that a randomly selected sample less than pk is approximately k%. Okay. So intuitively speaking, if we have a sample and we line all the samples up from minimum value on the left and maximum value on the right, the K percentile is a value, which means on the left-hand side of the K percentile, there are k% of all data. And on the right-hand side of the K percentile, there are 1 minus k% of the data. Okay, this is an intuitive understanding of the K percentile. And these three steps gives us the method to calculate or to find K percentile. Okay, you can take a photo of this and or to write it down on your journal. We'll use it to do an example later. Okay, I'll give you 5 minutes to write them down in your journal or notebook. And then let's have a look at an example. Okay, let's see an example of how we can get the kth percentile. Okay. For example, if we have a sample set as follows: minus 12, 8, 10, 13, 15, 18, etc. And we want to find 25th percentile. Okay, following the three steps to find is 25th percentile. First, we need to sort the sample in ascending order, which is already done. Okay, from minus 12, 8, 10, 13, 15 to 36, 36, 38, 60, which is already sorted in ascending order. Okay, so the first step is done. As the second step, we need to find the location L25. Okay, L25 is n plus 1 times k divided by 100. Because here k is 25, right? So L25 is calculated to 6.5. Okay, this is a location of P25. And the third step, then we can find the value of P25. It is the integer part of the L25, which is 1, 2, 3, 4, 5, 6. It's here, right? Here, the integer part of the L25 plus the next element minus this element. Next element is 19 minus this element, which is 18, times the decimal part of L25, which is 0.5, right? So the final result is 18.5. This is the 25th percentile, P25. Okay, so basically the P25 is here. That means on the left-hand side, the relative frequency is 25%. And on the right-hand side of P25 is the rest 75% of all the data. Understand? Okay, any questions? Okay, if you have no questions, I'll leave this practice for yourself, okay? I'll give you 5 minutes to do it by yourself. Okay, use the same method to find P50. P50 is also called the median because on each side of P50, there are 50% of all the data, okay? The sample is the same. Please find P50 by yourself. Okay, did you finish?
Yeah.
All right, let's have a look at this together. To find the 50th percentile, first we need to sort the samples in ascending order, right? Which is already done because minus 12 is a minimum, and then 8, 10, 13, 15, 18. The sample is increasing until it goes to the largest value, which is 60. Okay, and okay. Second step is to find L50. L50 is a minimum of n and n plus 1 times k over 100, which is the minimum value of how many? Okay, 25 samples, right? So n is 25. Here we have 26 times 50 divided by 100. So it's a minimum value of 25 and 13, which is 13. So the location of P25 is 13th element, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which is 26. Okay. So this is our P50, which is also the median, because on the left-hand side, there are 50% of all elements. On the right-hand side of this element is the rest 50% of all elements. Okay, understand? You have any questions? No? Okay. And I'll leave you another 5 minutes to solve this question. Okay. Next, try to find the 75th percentile of the following sample using the same method. Okay, let's have a look at this together. So in order to find the 75th percentile, first we need to sort these data in an ascending order, which means minimum to maximum. Okay, this has already been done for you. So second step is to find L75, which is a minimum value of these two. Okay, which is 25, 26 times 75 over 100, which is the minimum value of 25 and 19.5, which is 19.5. So now we can find our 75th percentile, which is first locate the 19th element. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, which is 28. And plus the next element is 35 minus 28 times the decimal part, which is 0.5. And P75 is 28 plus 3.5, which is 31.5. Okay, any questions? Any questions? No? All right, let's see. Next concept. Next concept is called quartiles. This means that for a sample that is sorted ascendingly, we divide this sample into 4 parts. Each part consists of 25% of all the data. And the first number here is called Q1, which is first quartile, or sometimes they call it the lower quartile. And the one in the middle is called Q2. And this is also the median, or the third quartile. The third one is called Q3, which is third quartile, also known as the upper quartile. These 3 numbers divide all the data into 4 parts, and each part consists of 25% of all the data. So these are called quartiles, right? So in the summary, first quartile is Q1 or QL or lower quartile, which is also P25, right? Because on the left-hand side of the Q1, the percentage is 25%. The second quartile is also called Q2 or QM or median, which is P50, because there is 50% of all the data on the left-hand side of Q2. Third quartile is also called Q3 or QU or upper quartile, which is P75, because on the left-hand side of Q3, the percentage is around 75. Okay. Do you have any questions? So if a question asks you to find Q1, the only thing you need to do is to find P25. Or if it asks you to find Q2, You can either find the median or P50. If you want to find Q3, the only thing you need to do is to find P75 using the method we just discussed. Okay? For example, for the same sample, the first quartile is P25, which we have already calculated, which is 18.5 is about in here, right? This is Q1. Second quartile is P50, which we have already calculated around here, right? This is Q2. Okay, third quartile is Q3, which is P75, which is around here. This is Q3. And these three numbers divide this sample into 4 parts, and each part consists of 25% of all the data. Understand? Okay. Any questions? All right, if you have no questions, let's look at the third concept we're going to learn today. This concept is quite easy. It's called interquartile range, denoted as IQR. IQR matters. IQR is defined by Q3 minus Q1. That means if we have a sorted sample, this is our Q2, right? This is Q1, this is Q3. These three numbers divide all the samples equally into 4 parts. And this is IQR. IQR is Q3 minus Q1, which measures the spread of the middle 50% of the observations. Large values of this statistic means that the first and third quartiles are far apart, indicating a high level of variability. Okay, so IQR is a measurement that measures the level of variability of the sample data. Understand? You have any questions? No? All right, let's see the next concept. Next concept is called percentile rank or percentile score, which is actually pretty easy to understand. This is a reverse process to the process in which we find the case percentile. What does it mean? It means that if we sort all the elements from minimum to maximum, for each element, for example, here we have an element x0. Each element has a percentile rank. The percentile rank is a probability or proportion indicating on the left-hand side of x0, what is the percentage? This percentage is called the percentile rank. Okay, for example, if we have a x1 here, the percentage on the left-hand side of x1 here is called the percentile rank or percentile score of x1. Okay, so let's make a summary that how to calculate the percentile rank of a given element. Okay, for a given sample set size with size n for any element xk, the method to calculate the percentile rank of this element is as follows. First, sort the sample in an ascending order. Second, calculate number of elements that are less than xk, denoted as C. Third, calculate the frequency of xk, denoted as F. Then the percentile rank of xk is C plus 0.5 times F over N, multiplied by 100%. Okay? And then finally, let's look at how to interpret the percentile rank of any given element. Okay, the percentile rank of any given element means that if we randomly chosen an element from the sample, the probability of this element Px is less than this given element is the percentile rank of this element. Okay, please write this down in your notebook, and we'll use this process to do an example. Okay, I'll give you 3 minutes. Write this down, and then let's see an example. Okay, let's see an example. Okay, first of all, let's mention that. Let me mention that median Q2, the percentile of the median or Q2 is 50%, right? Because if you randomly select an element, the probability of this element lies on the left-hand side of median is 50%. Okay, following the same principle, the percentile rank of Q1 is 25%, and the percentile rank of Q3 is 75%, right? Okay, let's see another example. For example, if we have a sample set as follows, which has already been sorted in an ascending order, and it asks you to find the percentile rank of 27. So follow the process we have just discussed. First, sort the sample in ascending order. Second, let's calculate the number of elements that are less than 27. Okay, 27 is here, and on the left-hand side is also element that is less than 27, which is 14. So we denote it as C is 14. And third step is to calculate the frequency of 27. Okay, 27 appears twice. The frequency F is 2. Okay, frequency F here is 2. And then finally, we can calculate the percentile rank of 27, which is C plus 0.5 F divided by N times 100%, which is 14 plus 0.5 times 2 over 25 times 100%, which is 60%. So this is a percentile rank of 27, which means that on the left-hand side of 27, there are 60% of all the data, which also means on the right-hand side of 27, the percent is 40%. Okay, any questions? No? Okay, so the last concept is called z-score. Z-score is the distance between a measurement x and the mean, expressed in standard units. Use of standard units allow comparison across data sets. Okay, we will not talk about this much. The only thing you need to do is to remember these two formulas. For population, the uppercase Z is x minus mu divided by sigma. For a sample, the lowercase z is the lowercase x minus the mean divided by the standard deviation. This is the way how we can calculate the z-score. Okay. The use of the z-score is to draw the box plot. Again, this is only an introduction. The only thing, you don't need to know much about the box plot. Here, at current stage, the only thing you need to do, you need to know that we can use a box plot to describe the distribution of a sample set. Okay, in the box plot, the dots on the upper part or the lower part is called outliers. That means there are few data here or here. These are called outliers. Okay, the majority part of the box plot lies in the middle, which is a box. Okay, the upper part of the box is called Q3. This is Q3, and the lower part of the box is called Q1. Okay, upper edge is Q3, lower edge is Q1, and there is a line in the box. This line is Q2 or median. Okay, the only thing you need to do, you need to remember is that the box represents our IQR. This is our IQR, okay? And the lower edge is Q1, upper edge is Q3. And the line in the box is called Q2, which is the median. So the box represents the middle 50% of all the data, okay? And here is 25% of the data. Here is another 25% of the data, okay? All right, this is what we have learned today.